Hello and welcome friend. In this tutorial, I'm going to show you how to create this tic-tac-toe game in Godot. Take a look at the table of contents for the tutorial. And with that being said, let's go ahead and get started. So first of all, let's go ahead and start a new project. I'm going to call this TicTacToe YouTube. You can call it anything you like, and let's go ahead and pick a folder location for this. We can leave the renderer as forward and the version control as git, and then click on create. First of all, I'm going to create a new 2D scene. This is going to be the main game scene that everything is going to take place in, and because of that, I'm going to call this the game. We're going to save this, but first of all, I want to create a new folder that I'm going to use to store all of my scenes. So inside of my file system, I will right click, create a new folder. This will be the scenes folder. I'm going to do that one more time. And this time I'm going to create a folder called scripts, where I'm going to place all of my scripts. Now we can go ahead and save this scene into the scenes folder, just like that. Next up, I'm going to create a script for the game node right here by clicking on this button. The name of the script is fine, but I'm going to place it into the scripts folder instead of the scenes folder, just like that. Great, so we have our main game scene and script and also the folders to store these types of assets. Next up, we're going to import the graphics and the sound effects we're going to use for this game. I have prepared a folder for that for you to download, which is called TicTacToe assets.zip. If you want to get this, you can simply click on the link in the description, go into the free school community that we have, and in there, inside of the classroom, you can find the link to download these assets. Once you do that, you can simply right-click on it, click on extract, and then you're going to be able to use all of the assets we have for this game. We have some graphics for the board, for the shapes, and also the title. And we also have some sound effects that we're going to use. We're going to create a folder for these inside of the file system, just like we did for the scenes and the scripts. And then we're going to import all of them into Godot. And I'm going to give that to you as a challenge. So go ahead and create a folder. You can call the folder assets. And then I want you to import all of the assets that you downloaded into that folder. Pause the video, give this challenge a go, and come back when you're done. Alright, first of all, we will right-click in the file system and create a new folder called assets. And then we can go into that assets folder. We're going to select everything, and then we're simply going to left-click hold and drag them into the assets folder, just like that. So that was the challenge. Next up, we're going to start setting up the main game area. First of all, let's play this scene so that we can select it as the main scene. You can see that the window is a traditional game window. The width is very large and the height isn't that tall. For tic-tac-toe, this isn't really going to work because we want a more square-ish type of window. In order to change that, we will go into the project settings, into the window section right here. We can change the viewport width and height to play with the window size. We're going to set the width to be something like 450 and the height is going to be something like 600. So almost like a square, but not quite. Now you can see in the viewport that the game area is much smaller and the height is actually larger than the width. We can also play the game to see this as well. Like I said, this is going to be better for a game like tic-tac-toe. Now let's go ahead and give this a different background color. In order to do this, we can use a sprite 2D, or we can use a mesh instance, or we can just use a color rect UI node, which is what I'm going to do. Let's go ahead and create a new color rect. We can change the color of the color rect to give it a different color, just like that. And we want this color rect to cover the entire screen. We can do that by going into this menu right here and select the full rect option. This way, even if we change the window size, the color rect is always going to expand to cover all of it. But there's a small problem here. If we go ahead and try to use this, it's not going to work because we need to create a canvas layer for the color rect. Otherwise, it is going to disappear like this. So let's go ahead and create a canvas layer as well, so that we draw all of our UI in a different layer. And then we're going to drag the color rect onto the canvas layer to make it a child. And that way the full rect option is going to work, as you can see. But of course, we don't want to use this red as the background color, so let's find something more suitable. We're going to go into the HSV section here. I'm going to turn down the saturation to be something like 12. And then I'm going to play with the hue to find something yellow or orangish. Just like that. I think this color is going to work just fine. We can give this color rect a different name, like background. And we can also change the canvas layer name to be something like UI layer. Just like that. Next up, we're going to place down the title and the board graphics into the game area. But before we do that, actually, I'm going to click on the background and I'm going to lock this node by clicking on this option right here. And that is because the background covers a large area and I don't want to accidentally click on it and move it all the time. In order to fix that, we can click on this lock, and that's going to make sure that even if I click on it, I'm not going to be able to select it. You can also see that the node is locked from this icon right here in the scene tab. Great, so as I was saying, let's go ahead and bring these graphics into the game. We can do that by using a UI node, but we can also use a sprite 2D, which is what I'm going to do in this case. So we'll click on the root node and we'll create a new sprite 2D. We will do the title first, so I'm just going to rename this to be title, and then I'm going to give it the title.png, just like that. You can see that the title is white and it's also at the moment behind the background. To fix that, let's go into the canvas layer, into the layer settings, and let's place this at -10 so that it is behind everything else. And next up, we're going to change the color of the title because, as you can see, white isn't really going to work well with the background color. And since the title is white, we can simply click on it, go into visibility and change its modulate setting in order to give it a different color. For example, we can click on the modulate, turn down the value to be 0 in order to make it black, which is going to be a good color for this. Let's place it in the center. It is a little bit too big, so we'll go into transform and give it a different scale. Something like 0.5 might work. Just like that. That actually might be a little bit too small, so let's bump it up just a little bit to 0.55. Let's play the game to see what it looks like. And I think it is looking good. For now, we can just leave it here, and later on, once we have everything on the screen, we can play with its position and scale if we want to. Now let's go ahead and create the board. For that, we can simply duplicate the title. So we'll select it from the scene tab and hit Ctrl D in order to duplicate it. Then we can rename this to be the board. Give it the board PNG. Since we duplicated the title, the modulate setting also carried over, so the board is also black, as you can see. We'll move this down just a little bit. Let's play the game to see what it looks like. I think it looks good, but it's a little bit too large, so we'll go into the transform and maybe bump this down to be something like 0.45. That actually looks a little bit too small, so we'll just say 0.75. And I think that is going to be just fine. We can leave it here at the moment because in the end, we're going to position the board from our script. So this position isn't really going to be important, so we'll just leave it roughly where it's going to be when the game starts. Great, so I think this is looking good. One problem that you will see is when you resize the window from the top. As you can see, when you do that, the game doesn't look good. In order to fix this, we can go into the project settings. In window, we can scroll down and set the stretch mode to be canvas items, which is going to be the solution to our problem. If you don't see one of these settings, you can always turn on advanced settings, which is going to let you see more settings. So whenever I open up project settings, if there's a setting that you don't see, just like I said, just turn on advanced settings. And now with this, we should be able to play the game, resize the window, and the game is going to be resized as well. So that is going to be the initial setup for the gameplay area. Now I want to create a couple of quality of life features. I want to be able to hit the escape key and exit the game immediately. And I also want to be able to hit the R key and reset the current scene. And these two features are going to make it much easier to test the game. It's going to make it much faster. So first of all, for this input, we will go into the project settings, into the input map, and create two new actions. Quit and reset game. For quit, we're going to bind the escape key. And for reset game, we're going to bind the R key. In order to bind a key to an input action, you can simply click on the plus icon here. And then you can simply click on the button or the key that you want to bind. In this case, for reset game, we're going to hit the R key in order to bind the R key on the keyboard. Next up, we will go into the game script and actually use these inputs. To do that, we will bring in the process function, just like that. First, we will check for the quit input by creating an if statement, and we will check input is action just pressed quit. If that's the case, we can call getTree.quit in order to quit the game. Then we're going to do this one more time. If input is action just pressed, this time for reset game. And if this is the case, we will just call getTree again, but this time we will call reload current scene so that the current scene is reloaded. You can see that this line here is yellow, and that is because we're not using the variable right here, which is called delta. In order to get rid of this warning, we can simply put an underscore in front of it, and that's going to fix that. Now we should be able to play the game, hit the escape key and exit, just like that. And we also should be able to hit the R key and reset the scene. But obviously, since we don't have anything going on at the moment, we can't really see that. But later on in the tutorial, we're going to use this a lot. So next up, let's talk about how the board is going to work in this game, which is going to be the main area where the gameplay takes place. As you can probably tell, in TicTacToe we have a grid of cells and we have 9 cells in total. The players have the ability to click on these cells and place down shapes which are determined by the turn of the player. The first player is going to be X and then the second player is going to be O. In order to make this work, we're going to create a scene called a cell, and this scene is going to have an area 2D as its root node. An area 2D is going to make it very easy for us to detect when a player clicks on it. And when that happens, like I said, we're going to place down a shape. First of all, we're going to make this cell scene and we're going to make it work. And after that, we're going to generate these cells from our script in the game and we're going to place them down into the game area, just like that. So that is the rough game plan for the cells. Let's go ahead and create the new scene. This is going to have an area 2D as the root node, just like I said. We're going to rename it to be cell, and we're going to save it inside of our scenes folder. Inside of here, we're going to first of all create a collision shape 2D. This collision shape is going to be a rectangle. So from the inspector, we'll pick a rectangle shape 2D, and then we'll click on the shape again, and we're going to set the size to be 100 by 100. By default, you can see that the center of the scene is the center of the collision shape. I'm going to click on the collision shape and I'm going to move it to the bottom right, just like that, so that the top left of the collision shape is at the center of the scene. This is just going to make it easier for us to place down these cells. So that's the collision shape. Next up, we're going to create a couple of sprite 2D nodes. And these are going to represent the shapes. The first one we're going to rename to X, and we're going to give this the tttx.png as its texture. You can see that it is absolutely huge, so we're going to have to scale this down. But first of all, let's go into visibility and set its modulate to be black, just like we did for the board and the title. And then we can hold down the shift key, and then we can scale it down. Let's take a look at the scale. Something like that I think is going to work. We'll place it inside of the collision shape and we'll try to center it roughly. Good, so that's going to be X we'll go ahead and duplicate X. So let's just right click on it, click on duplicate, and we'll call this new one O. And we'll change the texture to be TicTacToe.png, just like that. For this, I'm going to move it a little bit to the left to center it a little bit better, just like that. So that is the node setup that we need to do for the cell. Next up, we're going to create the script. So let's click on the root node, create a new script. We'll place this inside of the scripts folder. And let's talk about what we need to do inside of this script. Well, first of all, we need to be able to detect when a player clicks on the collision shape. And after that, we need to be able to place one of these shapes into that cell. So we're going to actually make these sprites invisible at the start, and only when a player clicks on the cell, we're going to make one of these visible depending on whose turn it is. So first of all, we will create the ready function. And inside of ready, we're going to make these sprites invisible. I will go ahead and right click on these and make them unique names, so that we can access them easily using the percentage symbol and their name. And then we can access the visible property and set it to be false for X and for O, just like that. Next up, we want to detect when a click occurs. So first of all, we will go into the project settings, into input map, and we will create a new input action called click. And we're going to bind the left mouse button to this. So we'll go into the mouse button section and select left mouse button. Next up, we're going to look for this input here in the cell script, but we're not going to use the process function. We're going to use a function that we're going to get from one of the signals of the root node right here. So simply click on the cell root node, and then in the inspector tab here, go into the node section. Here, there's a signal underneath collision object 2D called input event. We're going to double click on this and connect it. This function or this signal is going to be emitted whenever there is an input event. And inside of this function as an argument, we have this event right here, and we can use this to check what type of input event occurred. We can create an if statement with this. So we can say if event.isActionPressed, and we can use click. And this if statement is going to be true if the input event was indeed a click. For now, just to test this, we can print something and we can say cell clicked. In order to get rid of this yellow warning, we can put underscores before the arguments that we're not using, in this case viewport and shape index, just like that. Okay, great. Now we should be able to place a cell into our game, click on it, and get the cell clicked print right here. So we'll go into the game scene. We will instance a scene using this button. Double click on the cell, and then we can place the cell into the game area. Let's place it into the center right here. Now I should be able to play the game, click on the center cell, and I should get a print, but I'm not getting it, and there's a reason for that. And the reason is the background UI here is consuming the input before we can give it to the cell. So in order to fix this, we need to click on the background, go into the inspector, into the mouse section, and for the filter, instead of stop, we're going to set this to be ignore. Now we can go ahead and play the game. Click in the center, and you can see that we're getting cell clicked. Awesome. The natural next step here is going to be making the X or the O shape visible after we click on a cell. So let's talk about how we're going to make that happen. First of all, we need to keep track of what shape this cell has. So for that, we're going to create a variable up here. But what should be the type of that variable? Well, in this case, we can create an enum that's going to represent the different states of a cell. We can call that enum the fill state. The first state is going to be fill none, for the case that the cell is empty. The second one is going to be fill X. This means the cell has an X shape in it. And finally, we have fill O, for the case that the cell has an O shape. If you don't know what an enum is, it's very simple. It's basically a collection of variable names just like this that you can use in order to represent different states. Now we can use this enum as a variable type and create a variable called fill type, or fill state, let's say. And we can set it equal to fill state fill none, because at the start of the game, the cell is going to be empty. And when we click on it, we can set this fill state to be fill X or fill O. But instead of doing that right here, let's create a function to handle that, which we're going to call fill. This function is going to take in a fill state. We'll call that the new fill state. And we can use a colon here in order to set that variable to be a type of fill state. This makes it so that we can't call the fill function with something random like an integer. It has to be a fill state enum. Inside of this function, first of all, we're going to check if the current fill state is fill none, because if the fill state is fill X or fill O, we shouldn't try to fill it again. Only in the case that the cell is empty, we're going to try to fill it. So because of that, we'll check that the fill state is equal to fill state dot fill none. If that's the case, we can go ahead and set the fill state to the new fill state. And after that, we can check if the new fill state is fill X or fill O, and depending on that, we can make the X or O sprite visible. So firstly, we will check if the fill state is equal to fill state dot fill X. If that's the case, we can make X visible, just like that. And then we're going to check if this is false, is the new fill state fill O? And if that's the case, we're going to make O visible. And I'm going to give that to you as a challenge. So go ahead and check if the fill state is O this time. And if that's the case, if that is true, I want you to make the O sprite visible, just like I did for the X. Pause the video, give this challenge a go, and come back when you're done. Alright, we're going to create another if statement here. This time it's going to be an else if. We'll check if the fill state is equal to fill state, fill O, and if that's the case, we'll make the O sprite visible. And now, instead of printing cell clicked, we can call fill, and we can give it a fill state. So first of all, we'll try fill state fill X. Let's play the game. Click on the center, and you can see that we are placing an X shape. And if I try to click more, it's not going to work because of this if check right here. Once we fill a cell, we're not going to try to fill it again. Let's also try fill O. And you can see that that is also working. Great. Now, in the end, we're going to use the fill state enum both inside of the cell script and also inside of the game script. But if it's inside of the cell script, we don't have an easy way of accessing it inside of the game here. In order to make this work, we're going to create a global script and we're going to transfer the fill state there. That way we're going to be able to access it both in the cell and the game scripts. So let's go into the file system, into the scripts folder. Here we're going to right click. We're going to create a new script and we're going to call this globals. Next up, we're going to go into project settings, into the global section. We're going to click on this icon and we're going to find the global script. And then we're going to click on add. This is going to make it so that the global script is a global script, and that way we can access it from any script inside of our project. Now we should be able to open up the global script. We can cut and paste the fill state enum there, and then from any script we should be able to access it. But you can see that we are getting these errors, and that is because now we have to add globals in front of all of these fill states. And that way it is going to work. And now we should also be able to use fill state here inside of the game script as well, which is exactly what we want. Okay, next up we're going to work on the turn system. At the moment when we play the game, we have a single cell inside of the board and we can only place down a single type of shape. And that is because inside of the cell script, we're calling the fill function always with the same fill state. Instead of doing it this way, we need to use a turn variable and we need to use fill X or fill O based on whose turn it is. We're going to keep track of all of that inside of the game script. So let's get rid of this. We're going to create a variable up here to keep track on whose turn it is. And in order to do that, we're going to create another enum type. This is going to be called turn state. it's going to have two different values, turn X and turn O. Then inside of the game, we're going to create a variable. We will call this the turn. And by default, we're going to set it to be turn state, turn X, because the X is always going to be player 1. Now we need to call the fill function of the cell based on the value of this turn variable, which means we're going to make a call to that function here in the game script instead of the cell script. But in the game script, we need to be able to access which cell that was pressed. In order to make this work, we're going to create a signal here inside of the cell, which is going to be emitted when the cell is clicked. And then inside of the game, we're going to call the fill function on that cell. So let's go ahead and create that signal. We will call this clicked. And instead of calling fill here, we're going to emit the clicked signal. We're going to use an argument with this signal. And that argument is going to be this cell. We're going to pass the scene to the signal so that the game script can actually call the fill function on the cell that was clicked. So here when we emitted, we're going to use the self keyword to pass the scene of the cell. This is all we need to do here. Then inside of the game, we're going to connect this signal inside of the ready function to a function that we're going to create here inside of the game script. And I'm going to give that to you as a challenge. Go ahead and connect the clicked signal to a function, and I want you to name that function onCellClicked. Pause the video, give it a go, and come back when you're done. Alright, inside of the game scene, we have the cell node right here, or the cell scene. We can access this by using the $sign and say cell. We don't need to create a reference for this, or we don't need to make this a unique name, because in the end, we're going to delete this and generate the cells from the script anyways. So for now, we'll just access it like this. We're going to say .clicked, .connect to connect it, and we're going to connect it to a function called onCellClicked. So let's also create this function. It's going to take in the cell that was clicked. Very important, don't forget that. And now whenever a cell is clicked, this signal will be emitted, and then in the game, this function will be called with the scene of the cell that was clicked on. So we can actually print the name of this in order to see it working. As you can see, when I click on the cell, the name of the cell is printed. We can actually create another cell. Let's actually create two more. I'll just hit Ctrl-D to duplicate these. So now we have 3 cells. So we're going to have to connect those as well. So I'll just copy and paste this line 2 times and connect cell 2 and 3 signals to the same function. Now I can play the game, and every cell that I click is going to print their own names. So because we're passing self to the signal inside of the game, we're able to access each individual cell that was clicked inside of the same function. Perfect. But printing their names is obviously not that useful, so let's go ahead and fill these cells based on the turn. But first of all, before we try to fill them, let's check the fill state of the cell. Is it filled already? If it is, we just want to return. We don't want to do anything. So we'll check the fill state. If it is not equal to global's fill state fill none, that means the cell is already filled, and in that case, we will just return early from the function. But if that's not the case, first of all, we should determine which shape or which fill state we should use. We can do that by checking the turn variable. If the turn is equal to global's turn state turn x, in that case we should use the fill state x. So let's create a variable up here, call it fill to use, and here we will set it to global's fill state fill x. Else, if the turn is not x, which can only mean the turn is o, in that case we will use fill to use fill o. Just like that. Now that we know which fill state to use, we can call the cell's fill function with the fill to use variable. And after we do this, we need to switch turns. If it was X's turn, now it needs to be O, and vice versa. We can do that by using a similar if statement. We will just copy and paste this. So if the turn was turn X, now we're going to set turn to globals turn state turn O. And in the else case, we will just set it back to be X. This is going to switch the turn at the end of the round, you could say. Great, so let's give this a go. The first one should be an X. After that, it's going to be an O, then X again. As you can see, it is working and we're keeping track of the turns. Now let's go ahead and generate the board from our script instead of placing these down manually. First of all, I'm going to delete these cells. Then I'm going to delete the code we have inside of ready because these references are not valid anymore. And then I'm going to explain how this works before we actually implement it. If you think about it, the game board right here is essentially a 2D coordinate system. We have positions in the x-axis horizontally, and we have positions in the y-axis vertically. The first position is 0 on the x and 0 on the y, and from here, if we go to the right, we increase the x position, and if we go down, we increase the y position. In total, we have 9 different positions here. In order to represent this coordinate system, we need to create a 2D array. We're going to call that cells. A 2D array is essentially an array that has arrays inside of it. In this case, the cells array is going to have 3 inner arrays in it. Each one of these arrays will have cells inside of them, and each one of them will have 3 cells to be specific. These arrays are going to represent the columns of this coordinate system. So this one will be the first column, this one will be the second one, and this one will be the third. They can also represent the rows, it just depends on how you set it up. Then we can use the cells array and we can access its elements by using 2 brackets operators. The first one is going to determine the horizontal position. So if we wanted to access this cell right here, we would place 1 here. And for the second one, we would place 0. And this would give us the cell at this coordinate. So that is how the 2D cells array is going to work. And in order to loop over an array like this, a 2D array, we need to use 2 for loops, one inside of the other. The first for loop is going to be for the x-axis. It's going to have x as its loop element, and it's going to loop for 3 times, one for each horizontal position. The second for loop is going to be for the y position, and this is also going to loop 3 times, one for each vertical position. In total, since the second for loop is inside of the first one, these are going to loop for 9 times in total, like I said. The first for loop is going to start at 0 on the x, and then the second for loop is going to loop over each element in the column. Then we will go into the second column, and then the second for loop is going to loop over each element here as well, and finally we'll go to the last column. The second for loop will loop over each one of them again. We're going to use these 2 for loops in order to create cell scenes and place them at each cell position inside of the grid. So it's a little complicated, but that is the plan. Let's go ahead and start working on this. First of all, up here, we're going to create a variable to store the cell scene. We're going to call that the cell scene. We will use the preload function to load it in. And we're going to use the cell.tscn file, of course. After that, we're going to create the cells array. We will assign an empty array to this. Unfortunately, in GDScript, we can't do something like this in order to create a 2D array. So instead of doing it that way, we're going to create the inner arrays, but we're going to do it when we do the for loop. We don't have to do something like this at the moment. Although we could do it if we wanted to. I'm just going to do it when we create the for loops. Next up, we're going to create a variable to keep track of the board size. This will be a vector2 I, which is a vector2 of integers, and it's going to be 3 by 3. And actually, I'm going to make this a constant because I don't want this to ever change, because our game is only going to be able to handle a 3x3 board. Next up, inside of the ready function, we're going to create that double for loop. The first one is going to be for the x. And this is going to loop for the board size dot x, which is going to be 3. Then we're going to create the inner for loop, which is going to be with the y, and this will loop for board size.y, which is also going to be 3. Inside of the first loop, we're going to append an empty array into the cells array. So we'll say cells.append an empty array, and this is going to be that inner array I was talking about. We're going to do this 3 times because it is inside the first for loop, and like I said, these arrays, these empty inner arrays, will represent the columns. The main action is going to happen inside of the second for loop. First of all, we're going to instantiate a new cell scene, and then we're going to add it into the scene as a child and also into the array. So let's go ahead and do that. We'll say cell scene dot instantiate. Let's save that in a local variable called cell. After that, we can add this as a child to the scene. Then we can add it inside of the array. So we'll say cells, we'll pick the inner array, which we can do by using the x loop variable. And then we can say append cell, just like that. Next up, we're going to set the position of the cell. We'll create a new vector too for this. And in order to make this work, we need to do a little bit of math. So we know that the cells of the board are 100 pixels by 100 pixels. So the width is 100 and the height is also 100, which makes the whole board 300 pixels wide. And we also know that the game width or the window width is 450. So that's the whole window. If you take away 300 from 450, we have 150 pixels left. And if we divide this by 2, we have 75, which means each margin here on left and right needs to be 75 pixels. Which means when we place the cells, we need to have 75 as the X margin. For the Y margin from the top, we don't really need to do any calculations. I'm just going to pick 250 because I think that's going to look good, which is going to mean we're going to add 250 to each cell's Y position. Great, so let's go ahead and use this in order to position the cells. For the X position, like I said, we'll start with 75, and then we're going to add X times 100, so that each time we go through an iteration of the for loop, we increase the position by 100 so that we move on to the next cell horizontally. For the Y, we're going to start with 250 margin, and then we'll do the same. We'll say Y times 100 so that each iteration of this for loop, we go down 1 position vertically. And finally here, I'm going to connect the cell clicked signal to on cell clicked. Great, this is going to be the for loop to generate the cells, but we're not done. We should also correctly position the board graphic as well. We want the board graphic at the center of the cells. The 9 cells that we're going to generate, the board has to be in the center, otherwise it's not going to make sense. So a second ago, we determined that this margin is 75, and we determined that the entire board is 300. We can divide this by 2, which is going to give us 150, and we can add that to 75 to get to the center horizontally. And we can use the same logic vertically as well. We have 250 pixels of margin here. Vertically, the board is also 300 pixels, so the half of the board would be 150. So we would simply add 150 to 250 in order to get to the vertical center of the game. So let's go ahead and use these in order to position the board. I'm going to make this a unique name. Then we'll say board global position equals vector2, 75 plus 150, and then 250 plus 150. Make sure to do this outside of the for loops. Let's go ahead and play and see if this works. Let's take a look at the remote tab. We should have 9 different area 2Ds, 9 different cells. Let's try to click on them. And as you can see, they're all positioned nicely, and the board graphic also looks to be correct. The ones in the bottom here, they do look a little bit too close to the line, so I'm simply going to go into the cell scene here. I'm going to select both of them, and I'm going to move them just a little bit downwards like that. And now I think it's going to look better. Awesome, so that is how to generate the board from our script. It's a little complicated, but hopefully it made sense to you. So at this point, we can play the game, we have the board being generated, and we can place down these shapes. So the next step is going to be checking for win. Let me explain how that is going to work. It's going to be a little bit complicated, but I'm going to try to make it easier for you to understand. So first of all, we're going to have 3 different win conditions. A horizontal win, which is going to look like that, a vertical win, which is going to look like that, and a cross win, which is going to look like that. We're going to write different pieces of code that is going to check for all 3 possibilities. First of all, in order to do a horizontal win check, we need to go through all of the rows of the board. So this one, and this one. And while we go through these rows, we need to look at the state of each cell. If all of the cells are the same shape, that means we have a win condition. In order to make this work, we can use a double for loop, just like the one we used to generate the board. The first loop is going to be for going through the rows. This is going to be the Y position. It has to be the Y position because each time we increase the Y position, we go down to a different row. At first, it's going to be 0. That's going to be this row right here. Then it's going to be 1, then 2, in order to go through all the rows. Inside of this for loop, we're going to have another for loop, and this is going to be the X position. And this one is going to go through all the elements inside of that row. In order to compare the states of these cells, we can simply look at the first one and then compare the first one to the other ones. So we will create a variable to save the state of the first one. In this case, let's say it's X. And then on the second or the third iteration of the inner loop, we're simply going to compare the state of those cells to the first one. If it's the same, we're going to continue. If it's the end of the row and they're all the same, that's going to be a win condition. If one of them is a different shape or it's empty, in that case, it's going to be a no win condition. In that case, we're simply going to break out of that loop and go into the outer loop again so that we can take a look at the next row. Or if you're at the final row, we're simply going to stop doing horizontal win checks. The vertical win check and the cross win checks are going to be extremely similar. In the case of the vertical, we're simply going to go through the columns in the outer loop, and the inner loop is going to take a look at the elements. And for the cross win, we're only going to use a single loop in order to look through the elements here and here. And there's a cool trick that we can use to do that, which is going to allow us to take care of this using just a single loop instead of a double loop, but I'm going to explain that more when the time comes. So first of all, let's go ahead and start with doing a horizontal win check. This is going to happen right after we switch the turns. In order to do the checks, we're going to create a function called checkWin, and we're going to call this right here. Before we do any checks, we're going to create some variables. The first one is going to be the win state. By default, this is going to be true, and this is going to determine whether or not we have a win condition. The next variable is going to be the first cell state, and this is going to be the state of the first cell that we're checking. By default, we're going to set this to be globals, fill state, fill none. And now we're going to do the horizontal win check. We're going to create the double loop like I told you. The first one will be Y, and this will be a range using the board size.y. And then we will create the inner loop, which is going to be the X position, which will be a range for the board size.x. Inside of the first loop, we're going to set the win state to be true each time we start the loop. And inside of the second loop, we're going to do some checks. to see if the win condition is there or not, and depending on that, we're going to set the win state to be false. First of all, we need to get access to the cell that we want to check. So we're going to index the cells array. The first index is going to be the X, and then the second one is going to be Y, and then we'll save this into a local variable called cell. This way, the first loop is controlling the row, and then the inner loop is going to go through the elements of that row. Once we have the cell, the first thing we need to do is check if this is the first cell inside of the row. We can do that by taking a look at the X loop variable here. If it is 0, that means this cell is the first cell. So if X is 0, we will save the state of X into the first cell state variable. So cell.fillState. But before we do that, we should check if the cell is empty or not. If it is empty, there's no point checking for a win condition in this row. In that case, we can just break out of the loop. So we'll check the cell.fillState. If it is equal to global's fillState fillNone, we will simply set the win state to be false. There's no win condition, and then break out of the inner loop so that we can check the next row. So this is what we need to do for the first cell, and then we'll create an else condition for the second and third cells. In that case, we simply need to check the state against the first cell state. Is it the same or not? So if cell.fillState is not equal to first cell state, that means the win condition is false. We'll simply set win state to false and break again. If we are able to go through this loop without setting the win state to false, that means all of the cells have the same shape or the same state. So after we end the inner loop, still inside of the first loop, we can check if the win state is still true. If it is, that means we have a horizontal win condition. So we'll say if win state is true, we can print horizontal win. And at that point, we can actually break out of the first loop as well, because if we have a win, there's no point going through the other rows. So let's play the game and see if this is working. We're going to try to get a horizontal win. And as you can see, we get the print. Let's restart and try again with a different row. And as you can see, it is working just fine. Next up, we're going to do the vertical win check, and it's going to be extremely similar to the horizontal win check. As a small challenge, if you want to, you can try to implement this yourself. All you have to do is going to be copying and pasting this code, and you're going to change some of these loop variables and how you check for the first element. All right, I'm simply going to copy and paste all of this down here. We will change horizontal here to vertical. Then we're going to switch these for loops. The first one is going to be X, and the second one is going to be Y. The way we index the array is going to be the same, but the way we check for the first element now is going to be with the Y loop variable. And down here, we're going to change the print to vertical win as well. So with these changes, instead of going through all of the rows, we're going through all of the columns. The columns are controlled by the first loop because the horizontal position inside of the array is going to determine the column that we're looking at. And then the inner loop, which is the Y position now, the vertical position, is just going to go through all of the elements in that column. And because of that, now we need to use Y in order to check for the first element instead of X. But everything else is going to work the same. We're going to take a look at the first cell in the column. We're going to save that state into our first cell state variable. And after that, for the second and third, we're simply going to compare it to the first one. If it is not the same, we're going to break. We're going to set the win state to false. But if we are able to go through this loop without setting the win state to false, that means we have a vertical win. And in that case, after we end the second loop, we're simply going to check for that. And if it is true, we're going to print vertical win. And then we're going to break out of the first loop as well. Okay, let's play the game and see if this works. Let's get a vertical win. And you can see that we are getting the print message. Let's try that again. And one more time. And as you can see, all three possibilities are working. Awesome. Next up, we're going to do the crosswind check, which is going to be a little bit different. So let's play the game, and I'm going to try to explain how this is going to work. For the crosswind, we actually don't need to use 2 for loops, and there's a very specific reason for that. If you take a look at the coordinates for the crosswind positions, you will see that they are the same number for x and y positions. What do I mean by that? So look at the first one. This is the 0, 0 position. This one here is the 1, 1, and this one here is 2, 2. You can see that the x and y positions are the same number. In this case 0, in the case of the middle one it's 1, and in the case of this one it's 2. We can use this fact in order to simply create a single loop. Let's say it has I as its variable, and this is going to loop for 3 times. Inside of the loop, we can index the cells array, and we can use the same loop variable for both of the bracket operators. So the first time we go through the loop, I is going to be 0, and we're going to index for cells 0, 0, which is going to be here. The second iteration, I is going to be 1, and we're going to index for 1, 1, which is going to be here. And the final one, I is going to be 2, and we're going to index for 2, 2, which is going to be there. So that takes care of the first crosswind possibility. But the second one is not going to be that easy because these ones don't have the same numbers for x and y. But there is a trick we can use to still get this done using a single loop. So let's also write the numbers for these. This is 2, 0. The one in the middle is still 1, 1. And this one right here is 0, 2. We can still use the same loop with the I loop variable. And when we index the array, this time for the first one, instead of just using I, we're going to use 2 minus I. And then the second one is going to be the same. It's going to be I. This way, in the first iteration, when I is 0, this number right here in the first bracket is going to be 2. And the second one is going to be 0. So we will start here at 2, 0. In the second iteration, I will be 1. We will take 1 out of 2, so this one will be 1, and this one will be 1 again. So we're going to index for the middle position. And finally, when I is 2, this first bracket here is going to be 0, and the second one is going to be 2, so we will get this one. So using this trick, we can also check for the second crosswind possibility. So that's how we're going to get it done. Let's go ahead and get started. After we do the vertical wind check, we'll do a crosswind check. Before we do the check, we'll set the wind state to be true, just in case it was set to false here. And then we will write that for loop. For I in range board size.x. You can use x, you can use y, it doesn't really matter as long as the board is a square in this case. First of all, we're going to get the cell that we're looking for from the cells array using I for both of the brackets. And then we're going to follow the same logic we had for the vertical and horizontal checks. We're going to see if we're looking at the first cell. So if I is 0, that means we're looking at the first cell. In that case, we will save the cell state in the first cell state variable. And before we do that, we will check if the cell is empty or not, because if it is empty, there's no point checking for a win condition. So if cell.fillState is global's fill state fill none, in that case, win state is false, and we will break out of this loop. This is what we need to do for the first cell, and then we will create an else case here. And in the else case, we will compare the state of the cell to the first one. So if cell.fillState is not equal to first cell state, that means win state is false, and we need to break out. After we go through this for loop, if the win state is true, that means we have a crosswind. So as a small challenge, see if you can write the if statement that's going to check for the win, and if that's true, go ahead and print a message that says crosswind. Alright, so we will say if win state is true, then we will print crosswind. and we will actually print crosswind 1, which is going to be the first possibility of a crosswind, and when we check for the second one, we will print crosswind 2. We're going to do the second check in the else case that we're going to create for this if statement. So we will do the first crosswind check. If we have a win condition, we will simply print crosswind 1. Else, if we don't have the first crosswind possibility, we will do the search for the second one, which is going to be identical except for the way we index the cells array. So we can just go ahead and copy and paste this into the else case right here. Make sure the indentation is all correct. And then we're simply going to place a 2 minus inside of the X index right here, so that we check for the second possibility for the crosswind. And after that for loop is over, we're going to do a check for the win state again. So if the win state is true, that means this time we have a crosswind 2. All right, let's go ahead and see if this is working. This is the first possibility, and you can see that we got crosswind 1. Let's try that again. And you can see that this is the second possibility, crosswind 2. Great, with that, all of the win checks are working. So now that we're checking for the win conditions, let's also do the check for draw. We're going to do this after we do all of the win conditions. So first we're going to do the horizontal checks, then the vertical, then the crosswind checks. And if none of those are true, we're going to check for draw. The draw check is going to be much more simple because at this point we have concluded that we don't have a win condition. So the only thing we need to check is whether or not all of the cells are filled. If all of the cells are filled and none of the win checks worked, that means we have a draw. But even if a single cell is empty, we don't have a draw just yet. So those are going to be the rules we need to follow. So let's go ahead and start writing the draw check at the bottom of the check win function. First of all, we need to make sure that the win state variable is false, because if it is true, we don't have a draw, we have a win condition. Then we're going to create a variable, and this is going to be isDraw, and by default this is going to be true. So automatically we're just going to assume that we have a draw, and then we're going to check all the cells in the game, and if one of them is empty or multiples of them are empty, we're going to set isDraw to be false. That is how we're going to do this. And in order to go through all of the cells in the game board, we're going to write a double for loop. This for loop is going to go through all of the cells one by one, and it's going to check if the cell is empty or not. And writing this for loop, or the for loops, is going to be your challenge. Go ahead and write the for loops to check for a draw, and for bonus points you can also index the cells array inside of the inner for loop. Pause the video, give it a go, and come back when you're done. Alright, let's do this. So the first for loop is going to be for the x position. We'll do a range for the board size dot x, and then the second one we'll do for the y position. Although it's not that important, you could do y first and x second, it would still work. Inside of the inner loop, we're going to index the cells array, and we'll use x and y just like that, and save this into a local variable. After we have this, the only thing we need to check is the fill state. Is it empty or not? So if cell.fillState is globals fill state fill none, that means we don't have a draw. So we'll set isDraw to be false, and then we'll break out of this loop because there's no point checking the other cells. Even if a single cell is empty, that means we don't have a draw. So this break is going to break us out of the first loop, or the inner loop I should say. And after that we still need to break out of the outer loop. So after we do the inner loop, we will check if isDraw is false. If that's the case, we will break out of this one as well. If we are able to go through all of the iterations of these loops without setting isDraw to false, that means we have a draw. So at the end of all of this, after we exit out of the loops, we will check if isDraw is true. And if that's the case, like I said, we have a draw, so we will just print draw. And this is going to be the draw check. Let's play the game and see if this is working. And as you can see, it is indeed working. Let's try a different combination for a draw. And it's also working. Awesome. So that's how to do the draw check. So now that we have all of the win conditions in place and also the draw condition, let's go ahead and actually visualize this on the screen instead of just printing cross win or horizontal win. In order to do this, we're actually going to highlight the shapes. So for example, in this case, we have a cross win, so we would highlight these shapes to a green color in order to make it obvious that there is a win. We're going to do this by creating a couple of helpful functions inside of the cell script. The first one is going to be called change color. It is going to accept a new color, which is going to be a color class, which is a class that lets us represent a certain color. We're simply going to take this new color and we're going to change the modulate property of the X and the O shape sprites. First of all, we will get X, set its modulate to the new color, and then we will do the same for O. Just like that, we have a useful function that we can call to highlight the shape to a specific color, and then we're going to create another function called highlight, which is going to take in a boolean called enable. This is going to be a boolean. If this boolean is true, so if enable is true, we're going to change the color to a green. Inside of the color class, we can access a bunch of pre-made colors, as you can see right here. The one I'm going to use here is going to be light green. And if the enable boolean is false, we're going to set the color back to black. So we'll say change color, color.black. Now we can use this function in order to highlight a certain cell to a green color or highlight it back to being its original color, which is black. Now we can go back into the game script and we can actually highlight the win conditions starting with the horizontal win condition. So instead of printing horizontal win, we're actually going to loop through the row that was the win condition and highlight each cell. In order to do that, we can simply get the inner loop right here, which goes through the elements of the row one by one. We can actually get the indexing of the array and the local variable as well. And we will print it or we will paste it right here into the if statement. And then all we have to do is to call cell.highlight with true. Inside of this if statement, we can still access the y loop variable because if you take a look at it closely, we are still inside of the outer loop. Let's go ahead and see if this works. Let's get a horizontal win. And as you can see, the cells are being highlighted. For some reason, this might give you an error about a node not being able to be found. If you get that, all you have to do inside of the cell is to, instead of using a unique name for X and O, is to create an onReady variable, let's say X sprite, just like that, and one for the O sprite. Just like that. So if you get an error like that, you can simply create these variables, and instead of using these unique names, you can use these variables instead, and that is going to get rid of the error. Just showing you this just in case you get that, because I did get that just a second ago for some reason, but it went away, so it seems a little bit inconsistent. Okay, so that is the horizontal highlighting. The vertical is going to be extremely similar. In fact, we can just copy and paste this down here where we have the print for vertical win. And instead of X, we're simply going to change this over to Y. Now we should be able to get a vertical win and get the highlight as well. As you can see, it's all working just fine. Let's also do the cross win highlighting. In order to do this, we're going to copy and paste this loop that is going to loop over the first cross win scenario. And then we will call cell.highlight true. And for the second one, we can just copy and paste this. And all we have to do is for the first index right here, we're going to add 2 minus. And that is going to take care of the second crosswind possibility. And as you can see, this is also working. Awesome. Finally, let's also do a color change for when we have a draw. Let's go ahead and change all of the cells to a red color. So instead of printing draw, we're going to use the same loop that we did up here. And we're going to call cell.changeColor this time because highlight only works with 2 colors. And we're going to use color.something light reddish like a coral color. Light coral, let's say. But feel free to use a different color if you have a better one. Now this loop is going to go through all of the cells in the game and it's going to change all of their colors to be light coral. Let's test it out. And as you can see, it works. One more time, just to be sure. Perfect. So that's how to highlight the cells for the win and the draw conditions. So at this point, we can play the game, we can have a win or draw condition, and we are highlighting it properly to show the player what's going on. But even after the game is over, we can still place down shapes. This is obviously not right, and we should have a game over sequence. So let's go ahead and implement that. First of all, when the game is over, we need a way of restarting or resetting all the cells to their initial state. For that purpose, we're going to go into the cell script and we're going to create a reset function. This function is going to set the fill state back to none. So we'll say globals, fill state, fill none. It's going to hide the X and O sprites. So we can say, I think we did that before actually, in ready. So we can just copy and paste that here as well. We're also going to call highlight with false, just in case the cell was red or green. Highlight false is going to set it back to be black. We're going to call this function when the game is over on each cell so that we reset the board to its original state. Next up, we will go into the game script, and at the bottom, we're going to create a function called restart game, which is going to be called when the game is over. Inside of this function, we're going to go through all of the cells using a double for loop, just like the one we used up here. In fact, we can just copy and paste this one. And after we get the cell, we can simply call cell.reset. This loop is going to go through all the cells one by one, and it's going to reset them. We also need to set the turn variable to X again, because at the start of the game, the X is always going to be the first player. And now we have a function that we can call when we want to restart the game. But when exactly do we want to restart the game? Well, right after we have a win or draw condition, we're going to highlight certain cells. Let's restart the game when the player next clicks on a cell after a win or draw. So for example, in this case, when I click again, instead of placing down an O, it should have restarted the game. That's going to be the plan. In order to implement this, we need to keep track of whether or not the game is over, and we're going to do that by creating a Boolean variable up here called isGameOver, and by default it's going to be false. We're going to set this to true when we have a win condition or when we have a draw condition. So inside of check win, right here for example, for the horizontal win, we're going to set it to be true. And we're going to do the same thing for vertical and cross and also the draw states. Right here for the vertical. Right here for the first crosswind check. And then here again for the second crosswind check. And finally down here for the draw condition. And then inside of the restart game function, we're going to set it back to false, because when we restart the game at the start, this variable should be false. Okay, now that we are keeping track of this, we can go ahead and actually call the restart game function. And we're going to do that here inside of onCellClicked. We'll do that at the top before we do anything else. First of all, we will check if isGameOver is true. We can also just say is game over, which is the same thing. And if that's the case, we'll call restart game and then return early from the function because we don't want to do anything else. We simply want to restart the game. Now we should be able to play the game, win or have a draw condition, and the next time we click on a cell, the game is going to be reset, as you can see. Let's also try this with a draw condition, and you can see that it also works. Awesome. With this, we have a complete game loop. We can essentially just export this and give it to a friend, and they should be able to play the game. But as a final improvement, let's also add some sound effects to this game, which is really going to improve how the game feels. If you take a look at the assets folder, you will see that we have 2 pop sound effects, and we're going to play these when we click on cells. To play them, we're going to create a couple of nodes. These are going to be audio stream players. We will call the first one pop sound 1, and then we will duplicate it to get pop sound 2. The first one is going to have pop sound 1 MP3 as its stream, and the second one will have the second sound effect, just like that. I'm also going to make these unique names. Now we're going to go into the game script. At the bottom, we're going to create a new function to play these sound effects. This will be called play click sound. And in this function, we're going to randomly select one of the sound effects to play. In order to do that, we're going to get a random number first between 0 and 1. So 50% chance it's going to be 0, 50% chance it's going to be 1. If it is 0, we'll pick the first one. If it is 1, we'll pick the second one. That is how we're going to do this. To get a random integer, we can call rand_i, and then we can use the modulo operator to limit this to a certain range. If we put 2, this random number is going to be between 0 and 1. Let's save this into a local variable. Let's say random number. And then we'll create a variable to hold the audio stream player. We'll call that toPlay, and we'll make this an audio stream player. Then we can check the value of random number. We can create an if statement. If random number is less than 1, which means it is 0, we will set toPlay equal to the first sound, which is pop sound 1. Else, if it is 1, we will set toPlay pop sound 2 to the second one. Now that we picked a random sound, we can go ahead and call toPlay.play to play that sound effect. Let's go ahead and actually call this function so that we can test it. As a small challenge, see if we can play or call this function at the right location inside of our script. Alright, that is going to happen inside of onCellClicked function after we do these first 2 if statement checks. After these, we can call it anywhere we want really. I'm just going to do it at the end after we call checkWin. Play the game. And as you can see, we're playing a sound effect whenever we click on cells. Awesome. One improvement we can do here is we can play with the pitch. If you take a look at one of these audio stream players, you will see that it has a pitch scale. This is a floating point number, which is set to 1 by default, and playing with this is going to change how the sound sounds like. We can give this a random number to get a slightly different sound each time we play, which is going to be great. So we'll say toPlay.pitch scale to access it, and we'll set this to be a random float from a range, and the range can be 0.85 to 1.15. So the default was 1, so we're either gonna go slightly below the default or higher than the default. This is going to be difficult to notice, but it is going to add some variety to the sound effects we're playing. Awesome, so those are the sound effects, and with them the game really feels a lot different. It feels a lot more alive. And that is basically going to be the game that we're going to build. We can also export it at this point if we want to send it to someone else, if we want other people to play, and doing that is extremely easy. All we have to do first of all is go into the editor section here and go into manage export templates. In here you have to be sure that you install the export templates. If you haven't done so, you can just click on download and install, and it's going to take care of that. It might take a little bit of time. And after you do that, you can just go into project, export. In here, you can create a preset for your operating system. In my case, it's going to be Windows desktop. Then if you want, you can pick a path. I'm going to pick my project folder. In here, I'm going to right click and create a folder called export. And in here, I'm going to save it. Let's also give this a name, TicTacToe YouTube. We don't really need to do anything else. We can just click on export project. I'm going to uncheck export with debug and then click on save. Once you do that, you can go into your project folder, into the export folder that we created. And here is the exe file and the pck file that you can send to your friends. Let's double click on it to see if it works. And boom, here's our game. We can play it, no problem, it works just fine. And we can change the window size, and the scaling also seems to be fine. So that's the end of the tutorial. If you want to continue learning Godot, take a look at this one as well.